Hello everyone, welcome to this tutorial by Zebra Code. In this tutorial, we are going to look at namespace in C++. Namespace is an essential part of C++. It is a big topic in C++. I will be covering this topic of namespace with two separate videos. The videos will use different examples so that I will be able to cover the topic completely. I will use the two separate videos to cover the same topic of namespace in C++. In this video, we will look at namespace from multiple libraries, scope resolution operator, and many other issues that are related to namespace in C++. The tasks that we will be covering during this tutorial will include looking at what is a namespace, why we use namespace, how to use a namespace, how to declare a namespace, then the scope resolution operator, how to create a namespace. We will look at what unnamed namespace is. We will look at namespaces from multiple libraries. We will look at namespace clashes. We will look at how to access namespace members, namespace aliases, namespace nesting, that is, namespace within a namespace. Then we will specifically look at some key facts about namespaces in C++. In C++, namespace is a big topic. But what exactly is it? A namespace is a logical way of grouping together functions and data that are related. We will see that in the course of this tutorial. In C++, somehow, namespace works like a class, but in a weaker and a lower concept than a class. Why do we use namespace in C++? Namespace allows objects of the same name to be used in different contexts without a name clash. The purpose of namespace is to allow objects of the same name to be used in different contexts without a name clash. You might want to use the standard output object, for example, cout, to mean two different things. In this case, the first would belong to the standard namespace, while the second would belong to another namespace. Some functions in your application could be from different software libraries, written by different programmers. They may do same thing or simply different things. This can potentially lead to a clash or a conflict in namespace. Software projects often involve large amount of code written by different programmers. Even if you are developing a very small application, you may want to use libraries written by other developers. This approach could expose you to name clash. The use of namespace can help to avoid name clash in your application or software. Using namespace, no namespace. Here is a C++ application. In this application, we are not using any namespace. So if we run it, we will have many errors and suggestions from the compiler. Some of the errors we will get will be endline was not declared in this scope, cout was not declared in this scope, string was not declared in this scope, error cin not declared in this scope. So here string, cout, cin, endline all belong to the standard namespace. Because we have not used the standard namespace here now, we will get these error messages. And there will be some suggestions. from the compiler. Those suggestions include std cout, which will be for this, std cin for this, std string, which is for this, and std endline. They all belong to the standard namespace. All these objects are from the standard namespace library. Now, using namespace, it's the same file we just saw in the previous slide. Here, if we say include iostream using std : cout, we are specifically referencing the cout object in the std namespace. That is the standard namespace. So if we run this application now, we will also get some error messages, or we can even look at it to see what possible error messages we would get. String name, this will fail. It is not specifically using string from namespace standard. Cout, hello world, this works. It is specifically using cout from namespace standard because here we declare that we are using std cout. So this will work. Cin name, this fails, not specifically using the cin from the namespace standard. Cout name, this works. It is specifically using cout from the namespace standard. We declared it here. Std cin name, this works. It is specifically using cin from the namespace standard. That is why it is going to work, because we said here std : cin, which means we are using the cin object from the standard namespace. Cout, I love C++, endline. This will fail. The reason for that is obvious. It is not specifically using endline from namespace standard, but it is specifically using cout, which we declared here. It is not using the endline object from the standard namespace. That is why it will fail. This one, cout, I love C++ programming. This works for two reasons. One, it is specifically using std : for the endline from the namespace standard, and it is also using cout, which we declared here as part of the standard namespace. So these are some possible errors that we will get if we run this application. Now, using namespace standard declaration, we have two files here. They are for the same program, but here we say include iostream using namespace standard. So all these objects we are using here, cout, cin, endline, are all part of the standard namespace. So everything will work perfectly well in this case. With this one, it will also work perfectly well. But look at the way we declare it here. Include iostream int main std : string. It's a part of the standard namespace. Std : cout, std : cin, std : cout, std : endline, std : cout, std : endline. They are all part of the standard namespace. So these two files will work. The program will run correctly because we have declared the namespace the correct way. Now, using namespace standard and the namespace standard objects. Here are two separate files as well, but they are for the same program. On this file, we say include IOString. With this line, we are specifically referencing some objects within the standard namespace. Here we say using std : cin, using std : cout, using std : endline, using std : string. What that means is that we are going to use these objects in the standard namespace. Because we have declared it here, we can use them in our application. And that is what we have here. Cout, hello world, cin name, cout name, cin name. Cout, I love C++, endline. Cout, I love C++ programming, endline. So we don't have any problem here because we declared it right here at the top. Why? On this one, we can use any of the objects inside the standard namespace because we have included it here. So we don't need to specifically select these ones. Any of them will work because they are all part of the namespace standard. In these two files, we have used two different methods to declare the standard namespace objects in these two files. This one includes everything by using namespace standard, while this one includes selected methods inside the standard namespace. Now let's look at the scope resolution operator when it comes to working with namespace in C++. What is the scope resolution operator? Well, the scope resolution operator is a mechanism that tells the compiler to look in the scope of the left-hand operand for the name of the right-hand operand. It is easy to understand. For example, here we have standard or std : cout, which shows that we want to use the name cout object, the cout object from the standard namespace. So if you look at it here now, the compiler will look in the scope of the left hand operand for the name of the right hand operand. That is, the compiler will look for cout inside the standard namespace. So this example explains the mechanism that the compiler uses to look in the scope of the left-hand operand for the name of the right-hand operand. We will see more of it later on in this tutorial. Now, more on using the scope resolution operator. Here, it's a program that has multiple namespaces, and this could lead to a possible clash. That is why we need to be careful with namespaces in C++. Here we say include IOString, include ocean.h. This is a library added here, int main. Now if you look at it, ocean : string name. So string is from the ocean library. It is an object from the ocean namespace. Std : string name. String is from the standard library. Std cout hello world, std endline. So by using namespace, we are able to avoid a clash between the string from the ocean library and the string from the standard library. And we use the scope resolution operator to reference both of them from their respective namespace. Referring to namespaces this way can be great. It can help to avoid clashes between namespaces. However, referring to library names with this notation can be awkward for beginners to C++. If you are new to C++, you will find this thing to be somehow cumbersome. That is, if you are a beginner to C++, you may even see this one to be too much code to type in this approach. You may just want to use the using namespace standard. However, when you get the hang of it, you realize its advantages. There are so many advantages why you would be better off using the namespace and their objects, just like we did here with these two lines. It can save you from spending endless time trying to debug your code. Namespace clashes can cause you to spend a long time trying to debug your code. Using namespace. Here is an application whereby we'll be using different namespaces. We want to create an application that lists all the cities in every country around the world. That is our project. For example, we will be looking at two specific cities: Oxford, UK, Oxford, United States of America. There are many Oxford cities and towns in the US. For example, Oxford, Mississippi, Oxford, Ohio, and much more. And there are Oxford cities in other countries around the world. So if we are actually building an application that lists the names of cities in every country around the world, there is a possibility of having a clash with different names. Or if we call one city, we may get multiple results. Or if we call one city, we may not get the expected result. So using a namespace in that process will help to solve that problem. Now here is an application. Include IOStream using namespace standard, and we have another namespace, United Kingdom. We also have another namespace here for United States of America. So if we say here string city, Oxford, England, United Kingdom, and here we say string city equal Oxford, Mississippi, United States of America. In our namespaces, we have two namespaces here now. That will be fine. So to use these namespaces in our application, in the main area, let's test it out. If we say cout city headline, we will get an error message because the compiler would complain that city was not declared in this scope. So the compiler doesn't know which city you are referring to. Well, if we say cout United Kingdom, that's the namespace, : city headline, this works fine because the compiler will understand that you are referring to this namespace United Kingdom, which is this one, and inside that namespace it will look for city, which is this one here. So it will print out Oxford, England, United Kingdom. For this one, if we say cout United States of America : city headline, this works fine because the compiler will understand that you are referring to this namespace for United States of America. So it will print out Oxford, Mississippi, United States of America. So you can see the advantage of using a namespace in C++. It helps to avoid clashes between names. We will see more of this later on in this tutorial. Now, creating a namespace. To create a namespace in C++, we use the keyword namespace. We give it a name and we follow it with opening and closing parentheses. The syntax for creating a namespace is illustrated here. For example, we have a namespace called ocean_level_watch. And looking at this sentence here on how to create a namespace, we started with namespace, which is the keyword here. Now we give it a name, which is this. Then the opening and closing parentheses, this one and this one. In between the opening and closing parentheses, we enter the code that we want to enter. Here we have void size, void average temperature, void composition, void. These are some functions that we are going to use inside this namespace ocean_level_watch. This is how you create a namespace in C++. I will say more about that later on in the video. We also can declare an unnamed namespace. And what does that mean? A namespace is unnamed if an identifier is not used during its declaration. That is, if we fail to use an identifier while declaring our namespace, it will mean that that namespace is unnamed. Here are 3 examples on the screen, and I will explain them one after the other. Let's begin with this one here. Include IOStream, include string. This one works because here we say using namespace standard. Now we say here namespace constant int main order equals 5. Int mass order, here int main cout main order end line, mass order equals 200, cout mass order end line. This one will work well. Why this one? It says include IOStream, include string. Using namespace standard, namespace constant int main order equals 5. And here we have a global variable int main order equals 10. So we have int main order inside this namespace, and we have here main order, which is a global variable. So if we say cout main order, the compiler will not understand what you are referring to because this namespace is unnamed. So you cannot really say now, look at the namespace I'm using and I'm going to use main order inside this namespace. Again, this one is a global variable with the same main order, with the same name. This one will not work because the compiler will be unable to differentiate the global name from the unnamed namespace member with the same name. Main order, main order. So the compiler will be confused and it will not be able to differentiate one from the other. Whereas with this one, it shows that we can extend an unnamed namespace. Here is a prototype of extending an unnamed namespace. Using namespace standard, which is fine. Here we have namespace, but there is no name for this namespace. It is unnamed. And inside it, we have a variable of data type double. Here we have a function and it's named product. Here we have another namespace, double price void product double s. If we say cout s, int main product price. So what we are doing here now is we are actually extending this unnamed namespace. So you can extend an unnamed namespace. Once again, when we declare a namespace and fail to give it a name, we say that namespace is unnamed. A namespace without a name as an identifier is said to be an unnamed namespace. And here we have an unnamed namespace because there is no identifier here. We also have here an unnamed namespace because this one has no identifier. And the same thing here, we have an unnamed namespace. It has no identifier, but we have also been able to extend here an unnamed namespace. An unnamed namespace can be extended. This is just a prototype of that, and it works. As a developer, there are some situations whereby you will be working with namespaces from multiple libraries, and this is one example. We will build on this example later on in this tutorial. Here is a situation. Let's imagine this situation. We are developing an application for NASA, we have a header file named solar_systems.h, and we have access to that header file. It is a library from NASA. And we have another header file named ocean_level_watch.h. It is a library from NOAA, NOAA, as part of our application. So this situation can lead to namespace clashes. Both header files were developed by different programmers, but have the following in them: void, size, void, void, average temperature, void, void, composition, void. These are some functions inside the two header files. Let's look at it critically once again. Let's imagine this situation clearly. We are developing an application for NASA. We have a header file named solar_systems.h. It is a library from NASA. And we have another header file named ocean_level_watch.h, which is a library from NOAA as part of our application. Both header files were developed by different programmers, but have the following in them: void, size, void, void, average temperature, void, void, composition, void. These are some functions in both files, and we will be using them in our application. Just to clarify what NASA and NOAA mean, NASA stands for National Aeronautics and Space Administration, while NOAA stands for National Ocean Atmospheric Service. Both agencies are owned by the government of the United States of America. So to develop the NASA application that we just saw in that situation in the previous slide, we would need these two header files. One will be the ocean_level_watch.h file, while the other one will be the solar_system.h file. Let's look at both. They contain exactly the same functions: void size, void average temperature, and void composition. The same thing here: void size, void average temperature, void composition. They have the same functions. This one here, void size, will show the ocean has a size of, while this one here, void size, will show the solar system has many planets. This one here, average temperature, will show the average temperature in X ocean, while this one here, average temperature, will show what is the average temperature in planet S. This one here, composition, will show ocean S is a body of salt water, and it goes on. And this one here, composition, we say planet Air has a radius of, and it goes on. So the three functions are available in both header files, and we need them in our application. In this situation, we could have a namespace clash or some namespace clashes. Let's see how we can work with it and avoid those namespace clashes in our application. Now, creating and adding namespace. This is the ocean_level_watch file. In the previous slide, we did not actually add a namespace ocean_level_watch. Now we add that namespace to it. So with this namespace added to it now, we can easily use this namespace file in our application by referencing it. For example, ocean_level_watch : size. So we'll be able to access this function with it. Now that we have added a namespace to this header file, we can access any of these functions through the namespace without having a clash with the other file. Accessing namespace members. There are different ways to access namespace members in an application, one way of doing so is to use the appropriate namespace together with the scope resolution operator. Members of a namespace can be accessed using the appropriate namespace in addition to the scope resolution operator. That will make it easy for us to access it. We simply need to use the appropriate namespace with the scope resolution operator. Namespace is open. It is unlike a class. New members can be declared using the namespace syntax. Namespace aliases. We can use an alias for a namespace. We can use a namespace alias to associate a shorter synonym with a namespace. That method allows a long namespace to be associated with a shorter synonym. Sometimes accessing a namespace can be awkward, especially if the namespace is very long. There is good news, and that good news is we can give a namespace an alias. How do we do that? It's easy to do. For example, in our application, we have ocean_level_watch, which is our namespace. Now using the scope resolution operator, : critical_mission. This is a long namespace. So we can shorten it or give it an alias or a synonym as namespace OLWCM. That is O for ocean, L for level, W for watch, C for critical, M for mission. You could give it any name. And we say equals ocean_level_watch : critical_mission. In this case, now we have given an alias to this namespace, and the alias is OLWCM. So this is how you give an alias. And when you are giving an alias, you still need to use the keyword namespace. So it means this is a namespace, and this is the name of the namespace, and it is equal to this long namespace. We don't have to be typing this one anymore. We will just use this alias. A namespace alias declaration begins with the word namespace, followed by alias name, this one, followed by equal sign, this one, then followed by the original namespace, which is this one, and ends with a semicolon, this one here. It causes an error if the original namespace has not been defined as a namespace. What that means is, if you have not defined this one, you cannot create an alias for it. A namespace can have many synonyms or aliases. All the aliases and the original namespace can be used interchangeably in a program. What that means is, if we are using this namespace, if it is added to our program, we can use the same long name as well as the shorter form for it. It will work. We can use them interchangeably, one or the other. A namespace alias can also refer to a nested namespace. For example, namespace SLS equals solar_system : planet. Then here we say SLS : Earth universe. That is about nesting namespaces alias. That shows how a namespace alias can also refer to a nested namespace. Now, accessing namespace members. This is a file to access a namespace members. The main.cpp application file, that is the main file for our application. We can add some header files here, but here it says include IOStream, include string. Now include ocean_level_watch.h inside double quotation marks. What that means is we are adding this header file, which was one of the files in the previous slides. Again, we are also including this one to our application, include solar_system system.h. They are both header files and they are inside double quotation marks. The reason we put them inside double quotation marks is that they are files or libraries we are including. They are not part of the standard C++ libraries. Here we say int main. In the body of the main function, we say ocean underscore level underscore watch colon size, which means we are using the size function inside the ocean level watch namespace. The same thing here, solar underscore system colon composition. This shows that we are using the composition function inside the solar underscore system. So this is how you can access namespace members in an application. Namespace within namespace, that is namespace nesting. We can nest namespaces. Here is an example of namespace nesting. We have a namespace here called NASA. This one and this one are the opening and closing curly brackets. So inside this namespace, we have void size, void average temperature, void composition as part of the NASA namespace. Then inside the NASA namespace, we have another namespace, exploration. And within the exploration namespace, we have a function, void missions. So we have here now two namespaces. Exploration is a namespace within the NASA namespace. This is called namespace nesting. That is a namespace within another namespace. We can have multiple namespaces within a namespace. In other words, we could have more other namespaces inside this NASA namespace. Accessing members of a nested namespace. We saw earlier how to access namespace members. But how do we access members of a nested namespace? That is also easy in C++. To do that, you use the scope resolution operator with all of the namespace names and follow the order in which they appear in the namespace declaration process. In our previous slide, we saw a namespace called NASA, and inside that namespace, there was another namespace called exploration, and inside the exploration namespace, there was a function called mission. Now, to access the mission namespace, we have to use the namespace with the scope resolution operator, and at the same time in the order in which they appear in the declaration process. NASA exploration mission. So now we are accessing a function within some nested namespaces. This is how you access members of a nested namespace in C++. We have talked about many things concerning namespaces. Here are some key facts about namespaces. A namespace is created using the namespace keyword followed by declarations within a pair of curly braces. We saw that in action. Members of a namespace can be accessed using the appropriate namespace in addition to the scope resolution operator. Namespace is open. Unlike a class, new members can be declared using the namespace syntax. Nesting. Namespace can be nested. That is, we can have a namespace within another namespace, or many namespaces within a namespace. It's like parent and child, or parent-children approach in object-oriented programming in terms of inheritance. To access members of a nested namespace, use the scope resolution operator. in addition with all of the namespace names following the order in which they appear in the namespace declaration process. A namespace can be declared using alias, and that is usually after it has been included as a header file. In other words, add a namespace file to your application as a header file, then create an alias from the namespace in your program. The using directives. That makes all names in the namespace visible and accessible without qualification with the namespace name. For example, using namespace flight simulation. The using declaration. For example, using flight simulation : test drive. This will make the test drive function in the namespace flight simulation visible within the file. It makes it possible to access the function test drive without the namespace name, flight simulation. An unnamed namespace can occur if the name of the namespace is omitted. For example, namespace. Now we are omitting the name of the namespace. We say here string product. This namespace is unnamed. It is important to understand that all C++ header files for the standard library add all their function names and so on to a namespace called std, which is short for standard. We have seen this in our previous applications and in the course of this video so far. Now that we have seen the theoretical aspect of using namespace in C++, let's look at the practical way of using namespace in C++. We will create a program for NASA and use some namespace files. But before we do that, subscribe to this channel. Alright, now let's create an application to demonstrate how namespace works in C++. I will be using the Sublime text editor for the work. You can use any text editor that you are happy with. Create a document or a folder for the project. Name your project NN work. That is NASA namespace work. I just abbreviated NASA namespace to NN. Then let it be NN work. You can give it any name that you are happy with, but I named mine as NN work. Now, inside our project folder, let's create a C++ file. I will name it cities.cpp. We will use this file to demonstrate how namespace works in C++. This will be an introduction before we do the main NASA application part of it. For now, let's enter some C++ code in our cities.cpp file. First, I will add some header files, include iostream, include string, using namespace std. This is for the standard namespace library. Let's add some namespaces. Namespace United Kingdom. Say here string city equals Oxford, England, United Kingdom. I'll add another comment here. Namespace for the United Kingdom. Now let's add another namespace. namespace for the United States of America. Here we are going to add a variable city of data type string. This time it will be Oxford, Mississippi, United States of America, semicolon. Now let's add our main int main return 0. Save it. So what is going on here? What we have here so far is easy to understand. Here we declare that we will be using the standard namespace, which is a part of C++, and here we are adding some namespaces, and here we add a namespace for United Kingdom. Here we have a namespace for the United States of America. Both of them have a variable named city, and it's of data type string, but the value assigned to the city variable is different for both namespaces, and we will be calling both of them in our program. The first thing now is, if we say here cout city and line, this will cause an error. This will cause an error for the compiler because the compiler doesn't understand which city you are referring to. If we run it now, we will get an error message. So let's run it. Let me open CMD, the command prompt here, and I'm going to navigate to where that file is. CD desktop and CD my intro and CD nn work. Hit enter. Great. I am inside this folder now. This is the path. Now let's compile it. G++ -0 run cities.cpp. Hit enter. Exactly. Here we have an error, and the error message is city was not declared in this scope, which is this one here. City was not declared in this scope. So I am going to comment this line out. To be able to print out city for United Kingdom, we need to use this namespace, and we will use the scope resolution operator for that. That will be cout United Kingdom, which is our namespace, : cd end line. Now if we run our code, it should work. This will print out Oxford, England. Let's compile our code and run it. Great, it was compiled successfully. Now let's run it. Run cities. This is what we are going to run. Hit enter. Great, it was run successfully, and it says here now Oxford, England, United Kingdom. So we have been able to use the namespace here now with the scope resolution operator to access the city variable inside the United Kingdom namespace. Now let's access city inside the United States of America namespace. To do that, we say cout United States of America. Then let's use the scope resolution operator, colon, colon. What are we printing? City. City. Headline. Oxford, Mississippi. Now let's compile our application once again and run it. Great, it was compiled successfully. Now let's run it. Exactly, it was run successfully, and now we have Oxford, Mississippi, United States of America. So we have been able to access city in both the United States of America namespace and the United Kingdom namespace. Without the namespace, we will have a clash in our application. For example, here we say using namespace standard. That is why we are able to use the object string, cout, and end line in our application. If we comment this one out, with this one now commented out, if we run our application, we will get some error messages. Let's try it. First, I'm going to compile it. Exactly. Now we have some error messages and suggestions. Here it says cout was not declared in this scope. Here it says city is not a member of United Kingdom. End line was not declared in this scope. So to fix that, we have some options. We could undo it and use the namespace standard, or comment it out here, say std colon colon, that's standard namespace. We are using the string object. Again here, std colon colon, we are using the string object from the standard namespace. And here, here, and here, we need to enter the same std colon colon. So with that, now we can run our application successfully. First, let's build it. Great, it was built successfully. Now let's run it. Exactly. So it's working perfectly well. Oxford, England, United Kingdom, Oxford, Mississippi, United States of America. So this is how you use the namespace name and the scope resolution to access objects in the namespace that you are using in your application. Let's do one more thing here about aliases. We'll say here, using an alias for a name space. That will be namespace. I will say here USA equals United States of America, semicolon. What we are doing here is easy to understand. We are creating a namespace with the name USA, and it is an alias for this namespace United States of America, because we have already declared it here, so we can give it an alias. So now, if I say here std string capital Washington DC, I have another variable now. It's of data type string and is named capital. So let's use the alias to access that variable inside that namespace. Print out the capital of the United States of America, cout USA colon colon capital. Yeah, we can add some text, say a capital, say capital city of let's say the capital city of the USA is capital. Okay, let me see here, std ::c out. Now let's save it and run our application, but before then let's build it. Great, it was built successfully. Now let's run it. Exactly, it was built and run successfully. The capital city of the USA is Washington, D.C. So we are able to access this capital from the United States of America by using the namespace alias USA. We could do the same thing for the United Kingdom. We can also create an alias for that. Let me quickly do that here. See, an alias for the United Kingdom namespace. That will be namespace UK equals United Kingdom semicolon. Now with this namespace UK, we can also access the variable city inside the United Kingdom namespace. That will be standard std : c out. This time that will be UK std end line semicolon there. So here print out Oxford, England, United Kingdom. Let's see, standard C out UK : Siri. Now let's compile our code once again and run it. Great, it was compiled successfully. Now let's run it. Exactly, it was printed out successfully. Oxford, England, United Kingdom. So this is how you use an alias for a namespace in C++. We have used the UK namespace for the United Kingdom namespace. Once again, before you can use an alias, the namespace has to be declared or included in your application if it is in a different file. This was just an introduction to using namespace in C++. Okay, we can also do namespace nesting here. That is, create a namespace inside another namespace. Now, let's create another namespace within the United States of America namespace. To do that is easy. I will leave a comment here. Namespace. Namespace nesting. I am going to create a namespace here for universities in the US. I will name it here university. I will be namespace university. And I will create a function for that. Let's leave a comment here. Create a function here. Void uni void. Std std string institutions. It's going to be an array. Let's set this to 4. Going to enter some universities here. MIT, Harvard, Stanford, one more, University of Florida, semicolon there. Do a for loop to print it out. For int I equals 0. I is less than 4. I plus plus. Std colon C out institutions I. Std colon headline. So what we have here now is a namespace with the name university within the United States of America namespace, and we have a function for that university namespace, uni. We have an array here of data type string. It has 4 elements in it: MIT, Harvard, Stanford, and University of Florida. Here we are doing a for loop. For int I equals 0. I is less than 4, because we have 4 here, and I plus plus. Now standard std colon C out institution I. So now let's call it in our main application. To call it, we need to use the declaration process. That is the way it was declared. That will be United States of America colon university colon uni semicolon. The first namespace is United States of America, then the second namespace is university, and this is a function inside the university colon. So this is how it was declared. Now let's save our work. Now let's save, compile, and run the program. Great, it was compiled successfully. Now let's run it. Exactly. Here we have MIT, Harvard, Stanford, University of Florida. I will leave a comment here calling the nested namespace. So this is how we call a nested namespace. We can also do the same thing for the United Kingdom namespace. I can just copy this one here and use it inside this United Kingdom namespace. I'm going to paste it right here now. Then I will change institutions to something else. Let's say 6. This one too will be 6. And now I need to change the names of the universities. University of Oxford, Cambridge University, University of Bristol, University of London, 2 more. Durham University. 1 more. Oxford Brookes University. Great, that's a long line, that's okay. Everything is exactly the same thing, except that this is now within the United Kingdom namespace. To access it is easy. You can see here std : cout. These are some universities. These are some universities in the UK. End line, and that'll be United Kingdom : university. United Kingdom : university : uni. Semicolon. Let's save it. Now let's compile and run our program once again. Great, it was compiled successfully. Now let's run it. Exactly, here we have the universities in the United States. Here it says these are some universities in the UK, and they are listed here: University of Oxford, Cambridge University, University of Bristol, University of London, Durham University, Oxford Brookes University. So this is a way of nesting namespaces in C++. You can add as many namespaces as you want. For example, here within the United States namespace, we can quickly add 1 more. This time I will call it namespace states void state name. I will just call this one here STS, abbreviation for states, and here I will put 5. These will be names of states. Call here Alabama, Alaska, Arkansas, California. 1 more. Ohio. 5 here. 1, 2, 3, 4, 5. Let's save it. We should change this one out to 5. Now change this one to STS. So what we have here is easy to understand. We are creating namespaces within a namespace. That is, multiple namespaces inside one namespace. To access it, we will have to follow the order in which they were declared. The first namespace is United States of America. The second namespace is university. The third namespace is states, and state name is a function inside the states namespace. So let's access that data. Accessing data within nested namespaces. United States of America, university, states, and what was the last one? Let's double check so that we get it right. State name. This is the function we want to access. State name, semicolon. Now what we have is we are trying to access state name function, and we are calling it in the order of the declaration for the namespaces. The first namespace is United States of America. Inside it, the next one university, and the next one states, and the function we are trying to access is the state name function. Let's save it, compile, and run our program. Great, it was compiled successfully. Now let's run it. Great, it was run successfully. Here we have the names of the states: Alabama, Alaska, Arkansas, California, Ohio. I think there is a typo there. We can fix that typo quickly. It's Arkansas. One important thing to quickly mention here is when you are nesting namespaces, you also close the curly braces in order of declaration. For example, the namespace here, university, did not actually close before we added state. We close it here right at the bottom. So you need to follow that order when you want to close the curly braces for your namespace or namespaces. So this is how you use nested namespaces in C++. Now with this one out of the way, the next task will be about the NASA project. We will use namespaces in that one as well. At the moment, we have only one file in our project. We will create more files for that. Like I said earlier, the topic of namespace is a big topic in C++. So this is the end of the first part of the 2 videos that I am going to do on this topic of namespace. The next video will be the second part on this topic of namespace. But before then, remember to subscribe to this channel. Thank you for watching, and see you in the next video.